This is problem number 6 from section 3.4. In this problem, they want us to solve the inequality, and they give us a quadratic inequality. Our first step is to write this so that it says 16x squared, subtract the 24x over, so it's minus 24x, plus 9 greater than or equal to 0. That's the first step, is always get your quadratic equal to 0, essentially. Now this says first step here, but that's if you have a quadratic already written like this. So after we do that, we're going to replace the inequality sign with an equal sign. So we're going to replace this now with an equal sign. And I'm going to use one of these methods to solve this. And I think the quadratic equation or the quadratic formula is the right step to take to solve this. So we're going to use the quadratic formula. I'm going to start by saying x equals negative 24 plus and minus root negative 24 squared minus 4 times a, which is 16, times c, which is 9. And that's all going to be over 2 times a, which is 16. So that's going to be x equals, and I'm going to start plugging some stuff in the calculator. So we're going to do the inside radical here, negative 24 squared minus 4 times 16 times 9. That gives you 0. So we're left with negative 24, this is 24 plus or minus 0 over, that's 32. So that gives you 24 over 32 for your x value. We can reduce that 24 over 32 if we divide them both by 4. We'll get 6 over 8. And divide them both by, well, we can divide them both by 2 again. So that's 3 over 4. Okay, so x value is 3 over 4 here. Now, notice we didn't get 2 solutions. We only got 1 solution. And we're trying to solve this inequality that's greater than or equal to 0. Well, let's pull back out what it looks like to have 1 solution, 1 real solution for our quadratics. Well, 1 real solution looks like a graph like this, where it touches just the x-axis 1 time. So our graph right here looks like this. The graph of this function looks like this, somewhere along this x-axis. And it doesn't really matter where. But we know that spot is actually at 3/4, so that spot is right here. Now, because it only touches the x-axis once, and this sign is greater than or equal to 0, that means that we have all real solutions, because our quadratic is always above the x-axis or touching the x-axis, right? Greater than or equal to 0. So because our graph looks like this, the solutions for this is all real solutions. Okay, so that's the solution for the problem. Now I do want to just change this problem very slightly. What if this did not say greater than or equal? What if? So I'm going to put what if here. What if we had 16x squared minus 24x plus 9 greater than 0? Well, now it still touches that spot, right, on the x-axis, but our greater than sign is not greater than or equal to. And so we have to be above 0. So our solutions have to lie above 0. So this would be all real solutions except x equals 3 over 4. Okay, so this is just a what if part. This part right here was not part of the problem, but this is a what if because That's an important piece of information to understand, is that the greater than or equal to makes it all real solutions because we're touching the x-axis. But if we have a greater than sign, we can't touch the x-axis, so the only spot that we're touching is at 3/4. Everything else is above. So we have all real solutions except that one spot. Hopefully that makes sense.